Thanks for joining us. My name is Valentin. Caramlhal. I'm managing infrastructure at Alessio, and together with Lucian, who's leading the core API product, we'll be talking about accelerating dApp development with indexed Ethereum data. So, short overview, we'll tell you a bit about Alessio, what we do, the new products that we've been releasing recently. Then we'll go a bit into building our data pipeline, and finally, Lucian will be diving into the core API. So about Alessio, we're a data analytics and visualization company. We do analytics on the Ethereum blockchain. We are a team of 20 people, mostly developers and data scientists. We're part of the Consensus Network, and our focus is to build tools that help a transparent interaction with the Ethereum blockchain. So this is a map of our analytics suite. At the bottom, there's the data services stack. We use this for in all of our products as a foundational raw interaction with the blockchain. So this data pipeline, do I have a, oops, sorry, just a sec. Cool. So this data pipeline interacts with Ethereum clients, extracts raw data, synthesizes it, and makes it available in a more accessible format for the layer above it to consume. So we built a number of tools based on this platform. The first one that we released 3 months ago is the EthStats Block Explorer. It's in beta, so you can check it out. I'll show the link in a second. And we're excited to announce 2 more tools in the suite, Alessio Monitoring and Reporting. So I'll briefly go over it because there's not enough time to demo it. But this is our Block Explorer. You can access it at that link there. Besides basic functionality of a Block Explorer, like seeing transactions, accounts, blocks, and all that, it also has some nice developer-oriented features. I'll highlight a few of these right now. So the first one is the message call trigger graph. So if you go to an arbitrary transaction, there's an option to see this call trigger graph. So you can see how that transaction interacted with the smart contract it was targeting and how that branched out into other calls. So this is really interesting if you're a developer and trying to understand the way the smart contracts interact, or if you're a security researcher, or if you're doing reverse engineering, this picture is quite helpful. A second one, there are multiple views to these graphs. So this one is another facet. You can see the accounts that were hit by the transaction. So you make a transaction to a smart contract, it branches out through some other calls, and then in this graph here you can see how all these accounts interacted together. So again, really interesting if you don't want to do reverse engineering or understand what went on in that transaction. Another feature, on the account details page, you have last 30-day balances in Ether and tokens. You can do a breakdown by tokens. So you can basically see how that account is doing in relationship to its holdings. That's like a total ETH balance, and it's also represented in US dollars. So I'll go over these really quick. This is the second product. This is our first open source release. It's an iteration of eatstats.net, if you know it, the network health monitor. You can basically volunteer your node to submit statistics to our platform, and we're going to do like you'll have some meaningful graphs like difficulty. You also have the synchronization state of your nodes in this chart here. So this one's open source on GitHub, on our GitHubs, and you can pretty much set it up for your private chains as well. If you know Puppet, the V1 of this was, you could set it up from Puppet as you'd set up a private chain. This is interesting, so check it out. Third one, blockchain monitoring. This is an alerting framework or product that we were putting out there. You can basically monitor any wallet or smart contract. You can customize the conditions on which alerts are triggered. For example, if you go above or below a threshold in the account's holdings, or if you're looking at a smart contract, you can alert by volume of function calls and a lot of other things that are meaningful if you're monitoring like core contracts, or if you want to do competitive intelligence and look at competitors' contracts. That's an interesting tool to use. And it can alert you on multiple channels like email, and we're coming up with other types of notifications as well. You can go to that link and see more about it. And finally, blockchain reports. this allows you to go over arbitrary segments in the chain history and on demand generate these reports. Currently we support this set of reports, but we interact and get feedback from the customers and see what's interesting and like what interesting queries we could create for them. This is backed up by Databricks, so it's pretty flexible in what sort of queries we can do, and even at scale. Cool, so I'll briefly go into our data pipeline, how we built it. The purpose is that we wanted to have a single point of raw chain interaction and not have to duplicate work across each product that we do. It's architected, it's running on Kubernetes. There are a few microservices chained that stream data as they transform it through Kafka. There are intermediary results available at each step, so you can tap into various formats of this transformed data. Some formats are useful for data science, some are more useful for the web apps. So basically, this data pipeline does the heavy lifting. First of all, it does run an ETH client pool, so it makes sure that it's alive, it's doing well, it's synced and everything. It's highly available. And the second role that it encapsulates is extraction, synthesis, and data enrichment. So by extraction, I mean it asks the clients like raw chain data that it can get directly from Web3 RPC and just stores that. Additionally, it synthesizes stuff like parsing the VM traces and figuring out the intermediate transactions that have happened, like internal transactions. We call them contract message calls. And finally, the way we enrich data is basically we interpret like known standards like tokens and extract that data and put it in an accessible format, or if there's a known contract, we can derive application level semantics from that. So we can indicate like, okay, this is like a bounty, or this was something else, right? And then finally, we do integrate with a number of partners that will also provide us additional data. The first one that we're going to be releasing soon is Mythics. They help us show security-related information on each smart contracts account page. So very soon in our Block Explorer, you could go to a random arbitrary smart contract and see what Mythics has to say about it. And finally, about service reliability. Like security, reliability also comes in layers. So the layers that we have put in place for our data platform, we have local assertions, so each microservice does its validations as it transforms the data, so like local level assertions. Then overall, after this data is persisted, we have a feedback loop, so there's a process that checks all this chain and makes sure that it's continuous and everything's well. If not, it can do some self-healing sort of behavior, as in it can re-trigger some processing of some blocks, and it does help in some situations, or just alert us. And finally, we do have replications in high availability configured. We kind of build this from the start. So this is cool. In a Kubernetes environment where you do maybe rolling upgrades of nodes, so nodes can come into existence and be taken out, it's really cool to have, I mean, it's essential to have high availability so that your replicas can pick up pods that were removed from the dying node, let's say. So this is about it, really brief about the data pipeline. Next up, Lucian will tell you about the core API. Thank you.
Thanks, Valer. I remember when I first joined Alessio and the team ran me through an internal demo of the data pipeline. It got me really, really excited because it spoke directly to most of the challenges that I was facing earlier in the days when I started developing my own apps on top of Ethereum. So there was a lot of talk back then about, you know, the good sides of Ethereum and the bad sides of Ethereum. It's decentralized, it runs smart contracts, it's expensive and so forth. But I didn't hear that many people talk about the ugly sides of it. And this sort of 100 extra engineering effort steps that I need to put up with if I wanted my app to reliably synchronize with the chain and to interact with what's going on there. So I guess my favorite example here is what I like to call the Schrodinger transactions. It's this funny situation that you have at the top of the chain when miners compete to produce blocks, and so your transaction could get into the chain, and then it could get out of the chain because it reorganized. And that's pretty difficult to handle, and I had no idea I had to code this myself. But then, even if you're doing that and you want to say monitor all the instances where you're receiving Ether at your address, you start realizing that it's not enough to simply monitor transactions, because you could have things like contracts sending money to your account. And then you could have multi-sig wallets and maybe receive prizes from bounty contracts, and then some other person called the contract, which called another contract, which in the end sent you the money. So if you want to capture all that, you've got to replay all the transactions on all the possible blocks and map out the entire set of interactions so that it can sort through the ones that directly affect your account. And then the matters get even worse when you realize that the blockchain itself stores all the data around the blocks. And most of the applications want the data centered around accounts. So if you want to display some kind of historical activity for an account, then you need to sort through the entire chain and do your own indexing pipeline, and then you need to keep this in sync with the chain as it progresses. And if you realize that you need more data, you're kind of back to square zero and start re-indexing again. So I hope it's not too far-fetched if I tell you that the moment when I saw the pipeline that Alessio was already developed, and I realized this is probably the closest thing I've seen in the blockchain developer space to a holy grail. Because not only it solved my own problems with my own app, but it was ready to assist any other Ethereum-based app and project that needs to handle Ethereum data in real time in a robust and reliable way. So then it kind of became our challenge to package this middleware that feeds at the root level from the raw activity that happens on chain, and then it processes it and it organizes it so that it can make it available to dApp developers and researchers and analysts in a way that it makes more sense to them. And so that they won't need to do all this kind of engineering effort in-house. So we realized, okay, we're going to design an API, and we wanted the API to be specific enough to be really useful for the use cases that we already knew people have, and general enough to handle lots of other problems that we hadn't thought about in advance. And we wanted to use open community standards all throughout the way. We didn't want to come up with our own terminology and with our own way of handling things. So we were really lucky to have had the data pipeline built already on top of the Ethereum ontology, which is a community-sourced standard, and then we use JSON API for serializing the data payloads. It's not, by the way, it's not any kind of generic JSON API. It's a very specific set of standards that you can check out. It's a pretty comprehensive project. And then we came up with this overarching view of how the API should behave if you're looking at it from a bird's eye view. And then we thought, well, we already have a pretty good block explorer, and that product lets you surf visually the entire ocean of information on chain in a clickable way. So you can start with a block, and then you can surf through transactions, and then move to accounts and the list of transactions and so forth. What if we could come up with the same kind of experience, but instead of clicking on screens, you're clicking on JSON data? And that's exactly how we structure the API. So you have, at the root level, you have resource collections. And these are the usual stuff, like blocks, contracts, accounts, and so forth. But then you can zoom into any resource. And then for every resource, you see a list of static attributes, and you see a list of relationships that link that resource with all the other resources that are relevant to it. So you can have for an account or for a contract a unified timeline of aggregated activity, including transactions and function calls and related log entries and so forth. So we're creating this full picture view of what's going on chain, and we're feeding this in a way that apps find it most relevant. So I'm really, really happy to announce that today we've launched the API. It's open for free access. You can sign up at leth.io/API, and you can start building on top of it. It's live on the mainnet. And as a concluding thought, I realized that I should have probably mentioned this in the first place, that this wouldn't have been possible without the incredible team effort that the entire Alessio team has been doing in the past years. And it's not only an internal team effort for us, it's a team effort with you, with the community. So I think as much as I'd love the work that we've been doing so far, right now this is the end of the lesser work. And the higher work is to hand it over to you and help grow this already incredible ecosystem. Thank you.